Pre-calc. Here we are with 7.4, partial fractions. We will learn to write a rational expression as the sum of two or more simpler rational expressions. For example, the rational expression x plus 7 over x squared minus x minus 6 can be written as the sum of two fractions. Okay, we're going to factor out that denominator to x minus 3 and x plus 2, and we're going to set up two smaller fractions with those denominators, x minus 3 and x plus 2, and it's going to be 2 on the top of that one and negative 1 on the top of that one, and we're going to figure out how to find the numerators of those. Each fraction on the right-hand side is a partial fraction, and together they make up the partial fraction decomposition. Okay, here's some rules. If it's improper, we're going to first divide it and then do the partial fraction decomposition of the remainder. If possible here, we're going to just skip to this one, factor the denominator completely into factors of the form px plus q to some power, or ax squared plus bx plus c to some power. And we can only stop here if the ax squared plus bx plus c is irreducible. If you can keep reducing it from here down to these linear ones, then we're going to keep going. Okay, for our linear factors, we're going to put constants above those. And for our x squared or quadratic factors, we're going to start the numerator with an x, bx plus c. So the a's, the b's, and the c's are just placeholders that we're going to solve for. They could be any letter. You could use any letter. Algebraic techniques for determining the constants in the numerators of partial fraction decompositions are demonstrated in the examples that follow. Note that the techniques vary slightly depending on the type of factors of the denominator, linear, quadratic, distinct, or repeated. And actually, we're just going to use the same method each time. That way we won't get confused. It makes the easy ones just a little bit longer, but it also only uses one process, so we don't have to worry about getting confused. All right. So, x plus 7 over x squared minus x minus 6. This was the example problem from the very beginning of the first page. Okay, and they said our denominator could factor to x minus 3 and x plus 2. All right, we still have x plus 7 on the top. Okay, so we're going to bring this over here and start a new line. We have x plus 7 on the top of x minus 3, x minus 2, nope, x plus 2, sorry, plus 2, and that is going to equal, now we're going to make two separate fractions where these denominators are on their own. X minus 3 on the bottom of that one, and x plus 2 on the bottom of this one. We usually just put a plus in the middle. Okay, so they're linear factors, so we're just going to start off with constants above those. We got a on top of there and b on top of there. Doesn't matter what letters you pick, they just usually go in alphabetical order. And now we're going to multiply both sides times x minus 3 and x plus 2. Okay, so that's going to cancel over here. And we're just left with x plus 7. Okay, over here, you could show this work. We'll just make another line or two. It's going to get messy. I think we can handle this in our head. If we're taking both of these two together times this one, and then both of these two together times this one. When I take these in together times this spot, times a over x minus 3, the x minus 3 is going to cancel out because I have one on top and on bottom, and I'm just going to be left with a times the x plus 2. And now on this one, the x plus 2 parts would cancel, and I'd have b times x minus 3. Okay, and the purpose of that whole step there was to clear out the denominators on both sides. We've cleared out the denominators on both sides, making this a lot easier to work with and solve. Okay, we're going to distribute over here. So now we're going to have ax plus 2a plus bx minus 3b. And we're going to rearrange and put our x's together. The regular, any terms that have x's together, so we have ax plus bx, and then we have a 2a and a minus 3b, so our regular numbers go together out here. I didn't write the x plus 7 down there, but it is pretty important to write it here, because now we're comparing, and we can actually go another step if you want to here and take the x out of both. But we're comparing here. My ax plus bx needs to equal, how many x's do I have over here? 1x. Ax plus bx, in order for these to match up, has to equal 1x. So I know a plus b has to equal 1. We could do another step. And when they do this, they put the x at the back. You can put it in the front. It doesn't matter. Right, we took the x out of both and put it out there in the back. You can put it in the front. It doesn't matter. But now it just makes it a little bit more obvious that we have 1 that needs to equal a plus b. The coefficients have to match. So we're going to set up a little equation over here. A plus b equals 1. Right, a plus b needs to equal 1x. And then our constant numbers here. 2a minus 3b needs to equal our constant number there, 7. So we have 2a minus 3b needs to equal 7. Okay, this is the easier spot to get one of the letters by itself. A equals 1 minus b. Just subtracted the b over. And now we're going to substitute 2 times 1 minus b minus 3b. So we have 2 minus 2b minus 3b equals 7. We're going to subtract this 2 over and have 5. Put these two together, negative 5b. And we get negative 1 for b. Okay, zoop, bring it on over here. 1 minus negative 1, a equals 2. So what do we do with these? Well, we're back up to here. So instead of a over x minus 3, I know we have 2 over x minus 3 plus b over x plus 2. Well, my b is negative 1 over x plus 2. Alright, got a little off-center there. Sorry. And that should match with the answer that they gave us earlier. 2 over x minus 3, negative 1 over x plus 2. Okay, well how's this going to equal this that we started with? Or the first one? Alright, if you were going to put those two together to add them, you'd have to get a common denominator, and you'd multiply this by x plus 2 top and bottom, and you'd multiply this one by x minus 3 top and bottom. And when you combined, we'd be left with x plus 7 over that. Okay? So here's where they're talking about linear factors. You could substitute the zeros in, and that would help you solve. I think it's just much easier, much more consistent just to follow along that way. So this process makes this level of a problem a little bit more challenging, a little bit longer than what it probably needs to be, but it also maintains a consistency of how we can do each problem, so we have a little bit more familiarity when we get to these tougher problems. For a repeated linear factor, You would use the coefficients in step 1 to rewrite and then substitute other convenient values. Okay, again, we're not using the zero method here. When we have repeated factors here, you'll see what we do. You have to build up to them, and we're going to mainly follow the quadratic rules, even for our linear ones. All right, let's take a look down here in the bottom. So step 1, factoring this denominator out, x, 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 we can take an x out in front. And this now factors to x minus 1 times x minus 1, which would be x minus 1 parentheses squared. So we have a repeated root. We have x minus 1 repeated. Okay, and we're going to see what that entails for us today. So we have our original, 3x squared minus x plus 5 over, and we're going to use our new factored denominator, x times x minus 1 squared. Okay, we have x by itself, so we're going to have a nice one here, denominator of x. And we put an a on the top of that. Again, whatever letter you want to put up there is fine. Okay, x minus 1 squared. Here's our repeated root. You have to build up. So we're going to have an x minus 1 to the first, and then we're going to have an x minus 1 squared. If you would have an x minus 1 to the fifth, was like right here, you'd have to have x minus 1, x minus 1 squared, x minus 1 cubed, x minus 1 to the fourth. You have to keep building up until you get all the way up there. So we have x minus 1 squared, so we're going to have b over x minus 1 and c over x minus 1 squared. Okay, now we're going to multiply both sides by our denominator, x times x minus 1 squared. Okay, we just cancel over here. We have a nice 3x squared minus x plus 5. Okay, now we have to think over here. When I take this whole thing to this one, okay, the x part would cancel out, and we're going to have a times x minus 1 squared. And then when I take this times this one, this x minus 1 on the bottom is going to cancel out one of those, so we'll have plus b times x minus 1. And then for the c part, the x minus 1 squareds would cancel out. We're going to have plus c times x. Okay, now x minus 1 squared. Man, this is an issue at all levels of math that I've taught. Algebra 1, geometry, algebra 2, and pre-calc. We get in a hurry and we just square the x and we square the 1. That's not what happens. X minus 1 squared means you have x minus 1 times another x minus 1. Foil that out. You should get x squared minus 2x plus 1. People forget about the minus 2x there in the middle, or the middle term that you would get from squaring a binomial. Okay, so when I take a to all three of those, we're going to get ax squared minus 2ax plus a. We're going to take b times x into both of these, plus bx squared minus bx, and then we have cx. We're going to rearrange and put these terms next to their matching x's. Okay, so we want to get the x squareds together. Ax squared plus bx squared. Regular x's, we have minus 2ax minus bx plus cx. And then our last one, we just have the lonely plus a. Okay, again, you could factor out the x spot, or, I think it's just common sense to be able to look up here. I guess we can write it down again. 3x squared minus 1x plus 5. So my x squared spots, ax squared plus bx squared, needs to match up with 3x squared. So I know that a plus b needs to equal 3. Okay, then my x spots. We have negative 2a minus b plus c. Those are all the regular x's. They need to equal negative 1. And then our last spot, usually they're going to have one that's pretty either easy for you, or it's going to be like up there where you can just substitute pretty quickly. Our last spot, our constant spot, our no x spot, we just have a that has to match up with 5. So a equals 5. Okay, we're going to take a equals 5, and we're going to put it over here. So we have 5 plus b equals 3. b equals negative 2. Now we're going to take that 5 and that negative 2 and put them in here. Negative 2 times 5 minus negative 2 from our b plus c equals negative 1. We got negative 10 plus 8. That's a c plus c equals negative 1. So this is, plus 2, my fault. How did that turn into an 8? I'm thinking one step ahead. Minus minus 2 is a plus 2. Now that goes together to be a negative 8. Now we're going to add 8. There's our plus 8 I was thinking about. And c equals 7. Whew. Now, you're not done there. What are you going to do with it? What are you going to do with it? We're going to come back up here. And this 3x squared minus x plus 5 over that equals this, equals, our a was 5, so we have 5 over x, plus b was negative 2 over x minus 1, plus c was 7 over x minus 1 squared. So this breaks apart into those 3 smaller pieces. Fun. All right. Let's keep this party rolling. Okay, we're going to have a quadratic factor. So on the bottom here, we can take out an x, and that would leave us with x squared plus 9. Okay, so this is not a repeated one like last time. This is just one term of x squared plus 9. And there's our x. 5x squared minus x plus 27 over x times x squared plus 9 equals, okay, we have an x that we're going to use, and we're just going to put a on top of that, plus the quantity of x squared plus 9. And notice it's not this one's squared. The squared is on the x that's part of the root. Okay, now this is a quadratic root. Notice that our other ones have all been linears, just a single x in the denominator, so then our numerator just has a constant a. We have an x squared here, so we're going to start our numerator one level below it, which is still going to have an x. So we're going to have a b x to the first, because this was x squared, so one level below was x to the first. We're going to have b x to the first plus c. So if you have a quadratic root, the part that goes above it is going to be a letter times x plus another just regular letter. Okay, we're multiplying both sides by the denominator to clear out the denominators. Clear out, clear out. Okay, over here, the x's are going to cancel. When I take this whole group into this, the x's are going to cancel. Of a times x squared plus 9. And then when I do this one, the x squared plus 9 parts cancel. We're going to have the quantity bx plus c times just that x. Alright, so now it's the same process we've been doing. Let's see if you can push pause and simplify this, regroup things, and see if you can set up those equations and solve for a, b, and c and rewrite it. Okay, let's see how you did. We're going to distribute our a. We'll have ax squared plus 9a. And then this is going to be plus bx squared plus cx. Alright, let's rewrite it. You might not need to, but let's just do it just so we don't make any silly mistakes. We have ax squared plus bx squared plus cx plus 9a. Alright, look at our x squareds. We need a plus b to match up with 5. Alright, and now things get really nice because we just have cx, and there's only negative 1x, so c equals negative 1. And 9a equals 27. So a equals 3. We know c equals negative 1, and if a equals 3, b equals 2. And now we're ready to come up back over here and fill these in. So this is going to be 3 over x plus 2x minus 1, or plus a negative 1. If you really want to make it so you're dropping that in for just those specific letters. Okay, so we started here. We factored this, and so this fraction would be equal to those two pieces. Alright, last one for this video. There is one more problem, example 5. You can look at that in the book. It's just some long division, and then it's a pretty easy, actually, it's an easy fraction decomposition. It's just a long division to get there, because the numerator has a higher power of x than the denominator. But we'll do this one, and I know this looks like this one has a higher numerator than the denominator, but this is x to the third, and this is x squared squared, so really this is an x to the fourth on the bottom. It is a repeated root, x squared plus 3 squared. So we are actually all set to go here. We can't factor that anymore. So we have a repeated root. Remember, if we have a repeated root, we have to start with that root to the first. And then we build up. Thankfully, this is only squared, so we only have another one to go. Thankfully, this isn't like a cubed one. Okay, and remember with our quadratic ones on the bottom, our numerators have to start with x. So we have ax plus b, and that leaves me with cx plus d over here. Again, it doesn't matter a, b, c, d, what letter you use and where. Okay, it's just easier to start and go in order down the line. Okay, we're multiplying by x squared plus 3 squared. Just a clean cancel over here. Okay, when I bring this into here, this squared is going to cancel out with just this one on the bottom is going to cancel out one of those. So we have ax plus b times x squared plus 3 to the first. And then this parentheses squared totally cancel out there. And we just have plus cx plus d. Alright, let's multiply this out. We'll FOIL this out. Ax cubed plus 3ax plus bx squared plus 3b plus cx plus d. Okay? If you're really feeling it, go ahead and push pause here and you know what to do. If not, well, I'll continue to walk you through. We're going to rearrange. We got ax cubed plus bx squared, no other squareds, single x's, plus 3ax plus cx, no x's, we got plus 3b plus d. All right, let's take a look. 6x cubed, ax cubed. Ta-da! That's the only x cubed, so it has to match. A equals 6. X squareds, do you see an x squared over here? Nope. 0x squareds over here. So B has to be 0. Okay, we have 3ax plus cx, so 3a plus c needs to equal 16. Not a problem, we can do that. And then our regular numbers, 3b plus d. What do we have for regular numbers, for constants, no x's? We don't have one, so it's really a 0. So 3b plus d equals 0 as well. So take the ones we know and substitute them in. If a is 6, that's 18. Means c is a negative 2. And if b is 0, 0 plus d equals 0. That means d equals 0. All right, so we got all 4 spots, A, B, C, and D. We're going to come on up here and fill them in. So ax plus b, so that's going to be 6x plus 0, or just 6x, over x squared plus 3, plus cx plus d, that's negative 2x plus 0, or just negative 2x, over x squared plus 3 squared. Whew! So we started here, we broke it apart. We can break it apart into these two pieces. If you were to add these two back together, we'd get right back to there. All right, just a real quick peek. We're at 27 minutes, oh my goodness. This was a 2-day lesson, so you're getting both days crammed into one video. All right, so on this one, if the numerator is bigger, has a higher degree than the denominator, we're going to do our long division and then only do the decomposition with the remainder part. You're going to get x plus whatever over all of this, and then you're going to do the remainder part with that, with the decomposition with that remainder part. Okay? It's actually kind of easy because it's going to be small things, and it's just the long division in front of it makes for a lot of work. So, all right, best of luck. Let me know if you have any questions, and we'll see you next time.